Hey everyone! Welcome back! Today, we're diving into one of the most fundamental questions in physics: why does gravity exist? What is this invisible force that keeps our feet on the ground, shapes the stars, and holds the universe together? In the next minutes, we'll explore the origins of gravity, how it works, and the mind-blowing theories that try to explain why it even exists at all. Let's get started. Let's start with the basics. What is gravity? Simply put, gravity is the force that attracts objects with mass toward each other. But unlike forces we're used to, like pushing or pulling, gravity is different. It's invisible and acts at a distance. When you drop an apple, it falls because Earth's mass pulls it downward. But gravity isn't just something that affects apples, it's actually what holds planets in orbit, binds galaxies together, and even influences the shape of the entire universe. So how does this invisible force work? And why does it exist? To understand gravity, let's rewind a bit to some groundbreaking moments in science history. First, let's talk about Isaac Newton. Back in the 17th century, Newton developed the concept of gravity after observing objects falling toward Earth and pondering why planets orbit the Sun. He formulated the law of universal gravitation, which basically says that any two objects with mass attract each other with a force that depends on their masses and the distance between them. This was revolutionary. Newton's equations could predict the orbits of planets and explain why objects fall to Earth, but they didn't answer a fundamental question: why does gravity exist in the first place? Why do masses attract each other? The next big step in understanding gravity came from none other than Albert Einstein in the early 20th century. Einstein proposed the theory of general relativity, which completely redefined our understanding of gravity. According to Einstein, gravity isn't actually a force in the way we think about pushing or pulling. Instead, he suggested that massive objects warp the fabric of space and time, something we now call space-time. Imagine space-time as a stretched-out rubber sheet. When you place a heavy object, like a bowling ball, in the middle of that sheet, it creates a dip. If you place a smaller object, like a marble, near that dip, it will start to roll toward the bowling ball. Einstein's theory says that massive objects like planets and stars create similar dents in space-time, and this bending is what we experience as gravity. This idea was revolutionary because it replaced Newton's idea of gravity as an invisible force with the concept of curved space-time. But, while Einstein's theory describes how gravity works, it doesn't fully explain why gravity exists. What is it about mass that causes space-time to curve? Alright, so Einstein's theory gives us a great model for gravity at large scales, but there's still a major mystery. How does gravity work on a tiny, subatomic scale? This brings us into the realm of quantum mechanics, the science of the smallest particles. In quantum mechanics, gravity doesn't quite fit in. Other forces, like electromagnetism, are explained through particle exchanges, like photons for light. But gravity doesn't have a particle that we've observed yet. Scientists call this hypothetical particle the graviton, but it's never been detected. The field of quantum gravity is working to reconcile gravity with quantum mechanics, but we're still far from fully understanding it. In short, we know how gravity behaves at large scales, but why it exists on both large and small scales is still a mystery. So, we've talked about how gravity works according to Newton and Einstein, but now let's explore some theories about why gravity might exist in the first place. Theory 1, Gravity as an emergent phenomenon. One idea is that gravity is an emergent property, meaning it isn't a fundamental force like electromagnetism but something that arises from more basic interactions. Some scientists, like Eric Verland, suggests that gravity might emerge from the way information is distributed in space-time. If true, this would mean gravity isn't a built-in part of the universe but rather a side effect of other processes we don't yet understand. This theory is still very hypothetical, but it's one possible explanation. Theory 2, the holographic principle. Another fascinating idea comes from string theory and is known as the holographic principle. It suggests that our universe might be like a 3D hologram projected from a two-dimensional surface. In this model, gravity would be a byproduct of deeper principles working on a different level of reality. This concept is complex, but if it's true, it might explain why gravity behaves differently at different scales and why it's hard to unify with other forces. Theory 3, Extra dimensions. Another mind-bending idea is that gravity might actually exist in more dimensions than we can perceive. In string theory, for example, gravity could be leaking from higher dimensions into our observable universe. If gravity operates in extra dimensions, it might explain why it appears so weak compared to other forces, like electromagnetism. But proving the existence of these extra dimensions is incredibly difficult. So, why does gravity exist? The truth is, we don't fully know. Gravity might be a fundamental force, a product of space-time curvature, or even something that arises from hidden dimensions or quantum phenomena. But here's what makes this so exciting: every new theory and every new discovery about gravity brings us one step closer to understanding the universe itself. Whether it's keeping our feet on the ground, binding galaxies together, or bending the fabric of space-time, gravity is essential to our existence and still one of the most mysterious forces we know. Thanks so much for joining me on this journey into the science and mystery of gravity. If you enjoyed this video, please like, subscribe, and hit the bell to stay updated with more fascinating science topics. And let me know in the comments, what's your theory on why gravity exists?